is combustion, the good, the bad, and the ugly. We're going to talk about the reasons of bad combustion. We're going to talk about things and how to fix it. We talk about how it can happen and what to look for. So with that in mind, we're going to talk about combustion tonight. So small disclaimer. We have a lot of future plans to break a lot of these down into singular episodes and dive deep, much like Dave Nicholson did a few episodes ago on the negative pressure gas valve. So please rest assured that if you go, wow, that was fast, and whoa, that was quick, and oh my God, you didn't go deep enough into that, trust me, we will be going in the weeds on all of these. So that's coming along. Tonight, the panel and I will dive deeper at times if time allows, and we'll discuss things as we go through it. So cool. Get your handouts for tonight. On your little control panel on the right-hand side with the red arrow, if you click on that and go down to handouts, there's 5 handouts. There's a rebate program, of course. There's a vent calculator that you can calculate your length of vent and what your positive back pressure should be. You have the TRX FTVN, how to zero out the gas valve, because the guy you were working with didn't know the difference between the offset screw and the regular screw. The combustion setting high and low that we came out with for the TX and the FTV boilers. And of course, the CO2 calculator spreadsheet, because I find some people carry a much less expensive combustion analyzer that only gives you CO and O2. And of course, we dial in all of our boilers at levels of CO2. So that little calculator will help you explicitly. So, and we'll reintroduce those as the night goes on. So it takes 3 things for you to have combustion. It takes oxygen, it takes fuel, and it takes spark. You take any of them out of the equation, you're not going to get it. If you don't have enough oxygen, you get no flame. You don't have enough fuel, you get no flame. You don't have a spark, you get nothing. So this is the basis of what we plan on doing a lot of things. It takes 4 tools to test a boiler and test it for combustion. There's your manometers, or as Jason Mangos likes to say, a magnehelic is the only thing you can use. I beg to differ. I've been using a $40 TPI digital 9-volt battery. It works wonderfully. There's a multimeter, or what we all refer to as a multimeter. If you are England, they call it a multimeter, which made me almost lose my crap the other day listening to a guy from England give a presentation. You need a combustion analyzer. Doesn't matter if it's a $500 one or a $5,000 one, they all work, and you need one. Whenever you put in any modulating condensing boiler, I don't care whose brand it is, you need all of this. And wait a minute, that's only 3 tools. I said 4, right? Oh, the 4th tool is you. Because if you're talking to us or if you're on a job site, all these things have to do with you going through the boiler. And if you're talking to our tech department, you're talking to me, you're talking to Dave, you're talking to Jason, we're going to ask you for serial numbers. We're going to ask you what's going on. We're going to ask you to test things. You need to be in front of the boiler, calling our tech department and saying, my boiler won't fire. Well, then, are you on the site? And you say, no, call me when you are. So you've just wasted a phone call. So please be on the site and have all that information ready to go so we can start things up. So let's start with the most obvious. I like to go from the obvious to the more remote things that you don't look at. But I have to do this. This is our disclaimer for what to do. This is the first 4 pages of any installation operation manual. If you smell gas, don't start the boiler. Pretty easy. So leave and air out the house, please. If your CO detector starts to beep, leave and air out the house. If the homeowner is getting there and your CO detector is going off and they're complaining about headaches, they're vomiting, they have purple nail beds, for God's sake, do me a favor, leave the house and call 911 to come pick up the people and come back after the house is aired out. Good. And if the vent pipe is laying on the floor, before you reinstall it and start the boiler and leave and say there's nothing wrong, please do me a favor and find out what the problem is before you leave. And you're going to need all the above tools to do that. So cool. So let's start with the obvious. First, I have to start with a few questions. One, is it a new install? Meaning, did you just put it in and it won't start? It's a good question. Are you the service tech because the guys installing it didn't know? Or are you the installation tech that is trying to start it and has no clue and calls you, or are you all the above? Because I deal with a lot of companies where the installer is a service tech, but I deal with a lot of companies that have an installation department and a service department. And I know a lot of the installation guys have a tendency to not do a combustion analysis, not worry about it running. They flip the switch, they leave the house, and they go. So please make sure that you take care of that. If it's an existing boiler, how long did the boiler work well? Meaning, is it 4 years old? Has it been running a month? Has it been running 6 months? Is it propane? Because I don't even mention propane in this. In the cold weather, propane regulator is the biggest screw up, and you're going to need a manometer for that. So I do get into that. So was a combustion analysis ever done on this boiler? And do you have record of the original so we can compare it to the new? And this is extremely important. So, and what changed? I always like to look at what changed. So let's start with the easiest and work our way up. Visually inspect the venting, like incorrect installation. Here's a beautiful one that someone sent me. This is on a flat roof that you cannot see from the driveway. You cannot see it from the parking lot. You cannot see it from down the street. This is below the sides of the flat roof. And that CO from the exhaust is blowing straight down to the intake. Worst yet, they have a 3-inch intake and a 4-inch exhaust, which just floors me. So this is not a way to install it. Yes, we have 20 pages in our book on correct ways to install venting. Are there bushes or any?
Which page was this on, Steve?
What's this?
Which page was this on?
This is the incorrect page. This is the addendum to the installation operation manual. Is there bushes or other obstructions that are causing you not to get fresh air in or get air out? This is one of my most favorite pictures of a pancake vent that somebody thought the ants were coming in, so they spray foamed the intake of the pancake vent. This installation's been in quite a while and the foam's pretty new. So you know, as a service tech, you should have looked at the incoming and exhaust air intake and exhaust when you got there. So is the vent laying on the floor? And you have a broken termination on a concentric or a pancake vent. This is one of my favorites. Not only is it behind a condenser, but it also is behind the weeds that were growing up on it. And the end's been snapped off. And the reason the end was snapped off is because this homeowner was using that concentric vent as a place to hang his hose. And he pulled his hose off and ripped the end right off of it. So I always, when I get on a job site that you're having a combustion problem, walk around the house and look for the intake and exhaust. Hopefully you're there. I've learned to knock on the doors, especially when I'm on Long Island or in New York City. Because if I'm on Long Island, I've been chased by dogs, I've had guns pulled on me, and something told me I shouldn't go through the fence or jump it because it was locked. Little things that we have to, worry about. Blocked exhaust, vent check. So go to the exhaust test port with your manometer and put as much hose as you can into there. Remove the low voltage wire from the blower so it runs at 100%. The static pressure should be less than 1 inch. How do you know what it should be? See the handout called Vent Calculations _2.xlsx spreadsheet, and you can enter in your length, enter in your boiler, and it'll actually tell you the static pressure. But correct me if I'm wrong, Dave, it should be somewhere between 0.1 and 0.3.
It's going to depend on your vent size. And believe it or not, the vent calculation, we've got some smart engineers, it'll actually take into account the fuel type affects the type of venting as well as your CO2, but really all you have to worry about is vent length and boiler size. The maximum allowable on 2-inch venting on a 199 is actually 1.6 inches. And that's the maximum possible. Well, possible when you do it right.
Cool. That's awesome.
And if it's 3-inch venting, you're right. It's about 0.3, maybe 0.4 inches.
Yeah. So it's a nice, easy, quick way to see if you have a blocked vent without getting out your camera and running it down through the vent. Now, once you have a blocked vent, then you can run your camera down there and see what's blocking it. Could it be, I don't know, a bee's nest? Could it be a sparrow's nest? Could somebody have not put on the bird screen and there's a bat laying inside of there? Yes, I have pictures of bats inside of blowers and burner tubes, which is kind of amazing. So easiest in working our way up, visually inspect the boiler. This is a pair of boilers I got to, and they didn't know this. Was Dave and I are very familiar with this boiler. This is our original NTI boiler. The guy didn't know that you had to remove 8 screws in order to get to any of the safeties, and actually cut the jacket apart to get to the pressure switch and the manifold limit. He jumped all of those out, still ran the boilers. And if you look at the venting is almost black. In the picture when I was there, it was black. The one on the left looks white because of the light hitting it. But both sections that were black, and they used mission couplings or no-hub clamps on the venting, which is illegal to do. So this is not something you want. Inspect the boiler. Is there a water leak? Is the motherboard wet? I know that sounds stupid to say, but wow, Dave and I and Jason and Ted have seen a ton of motherboards that have gotten wet, and you just won't get combustion then because it shuts all the safeties down. Is the gas valve dripping? I always love that one. People, when they put in some of our boilers that have purges, open up the purge too far, and the trap won't take the amount of water you're gushing out. It fills up the boiler, and it actually floods the gas valve out. Do you have a fault code? Take a picture of it before you shut the boiler off, just so you know what it had first. Now, of course, you can always go back to history and see it, but when you call tech, it's often helpful to have the last one that you had there. So the gas, is the gas valve off? You know, I work in a lot of sections in Philadelphia that people don't pay their gas, and then they call the tech and say they don't have any heat. And then he gets there and he checks everything and turns the boiler on and off, doesn't do anything, and does everything but put his manometer on the gas valve to see if he has any gas. And then he goes outside once he determines he has no gas and sees that the gas valve is locked closed because the people hadn't paid their bill in 6 months. So stupid things to look, right? Easy to check with a manometer on the inlet side on the test port. It's a screwdriver on most of the Honeywell valves, and on the TRX FTVN gas valve, it is a T10 Torx. Don't put an Allen key in, you'll strip it. Trust me, I know firsthand. So let's start with the easiest still, work our way up, right? Visually inspect the electric. I know it sounds stupid, but I know a lot of places that have a switch at the top of the steps that's low, where the light switch is high, which is exactly opposite of what you're supposed to have, and the people turn the boiler off instead of their basement lights. This is a very common problem. In some places have 2 switches, one next to the boiler and one upstairs, and you see the one next to the boiler and turn it on, and they're in series. You're still not going to get any electric. So is the breaker on? You know, you can test it by opening up the boiler and seeing if you have electric on the terminals, on the black and white wires coming in. Use a multimeter, or multimeter, as we say here in the States, to check it. Black to white should be 120 volt. Black to green should be 120 volt. And white to green should be 0. I've been on multiple jobs in the past 12 months where I had anywhere from 6 to 14 volts between white and green, which means they're getting backfeed someplace in a bad place and their ground's no good. So this will screw up all your safeties on the boiler and lock it out from firing. Cool. Still going next level. Here we go. Check the Venturi. Now on the top right-hand corner is a TFT285 Venturi that happens to be white, the only white one in our group. And this one, if you look at that, looks like it has honeycomb. It's not supposed to look like it has honeycomb. It's just plumb wore out. I mean, this is from cross-contamination, rotting it out. Below is our 10-to-1 turn-down ratio, but look at the Venturi. Visually look at it. Is it blocked? I've had multiples this year where somebody has left a piece of trash inside the boiler or inside the incoming pipe, and it's gone into the Venturi and blocked it. Is it worn out like the one top right-hand corner? Wipe it with your finger. Is it black? Is it a 10-to-1 turn-down ratio with the flappers like on the bottom right-hand corner? Do the flappers flap? Do they flap freely? Check the orifices. In order to check the orifices, you have to pull it out of the metal housing. So you pop it out with a small screwdriver, you get underneath the tabs and work it out after you undo the 2 screws that hold it in, and check the orifices that are top and bottom. If you get horrible combustion at low and almost good combustion at high, chances are, especially with high CO, you're going to find that the top orifice is blocked. Yep, just corroded from shit sitting in the boiler. The blower. Oh, I've taken stuff out of blowers like, let me see, a leaf, a bee. I took a bee out the other day. What's that? 5 leaves. 5 leaves, yeah. I took a roach out the size of my thumb that had crawled in it in Philadelphia. Nice. So visually look at it. Is it blocked? Does it have a blockage in 1 or 2 of the veins? Is it worn out? Is it cracked? Does it spin free? How do you check to see if it spins free? Oh, that's right. Disconnect the low voltage wires with the power on, and it should run at 100%. And you should be able to hear if it's unbalanced. Look in the blades, like this one on the right. And I know on your screens you may not see this, so let me zoom in on it. Oh, where's my zoom in? There it is.
What do you got
See
in there? Acorn or something? You got some kind of something in there.
See the little screw? That was an extra part that was installed somewhere along the manufacturing line, either at the blower manufactured EBM or someplace at some factory that may have built this boiler. Yeah, a little 1/4-inch self-feed bit. Next thing we do is pull and inspect the burner. And while you have this out, you can inspect the igniter and flame sensor. We'll get to them in a minute. Somebody recently gave me a really good analogy on burners, and I've had this happen now twice in the past month from pulling air from the basement. Everybody on this call has a shop vac. Every shop vac has a filter on it, and I know those filters always stay clean, and you never have a problem with them getting dirty, right? Yeah. Well, this is a shop vac in reverse, because you're pulling air in at 40 mile an hour at high fire, and all that dirt's going right through the blower and right to the inside of the burner. It needs to be cleaned. You might say, well, how do you clean it? The way to clean it is not with compressed air and not with a rigid brush or toothbrush. The correct way to clean it is on this one. You would protect the insulation. You can take a bag, you can't get in Philadelphia anymore, a plastic bag that you shop with, and pull it over the burner and put it around the insulation. Hold it sideways, take it over to the sink, rinse the burner from the outside in. Then run water down through the burner tube and rinse the burner from the inside out. Then rinse it from the outside in again. Then shake it all about.
And do the hokey pokey.
A hokey pokey, and then reinstall it. Twice in the past 4 weeks, I've had this happen. Dave turned me on to this. Thank you, David. It worked both times. The boiler worked effortlessly and was beautiful. So you can also inspect the burner for burn holes. For instance, sometimes the igniter will warp towards the burner and burn a hole in the mesh. That burner needs to be replaced. Dave, you were going to say something?
Yeah, I was going to say another symptom of a blocked burner that sometimes is a little less obvious. I've had this probably a couple of dozen times now. If you get a boiler that midwinter seems to underperform, so it might be working perfectly, but just doesn't give you any heat, there's a very good chance that burner is plugged up or your venting is plugged. We see that multiple times every year. It could be dust, drywall dust. Please don't do that. Snow, ice, mice, ladybugs, mosquitoes in one case. So keep those burners clean.
Black fly is up in Ted's territory.
Yeah.
Yep.
So
Coming on black fly season.
Absolutely. So next up, pull and check and clean your flame sensor. Yes, if it's running and goes out and doesn't sense flame sensor. Yep. By the way, on a TFT boiler, it is very common to have modulation limitation due to low flame signal. This has nothing to do with the flame signal. It has everything to do with it could have something to do with the flame signal, but it has everything to do with increasing the speed on the blower to get the spark back, to get the electric back out of the flame sensor, get the sensor back up. So the igniters will do some funny things. Igniters will cause something called delayed ignition. And delayed ignition has been a big #1 for me this year. I have not had delayed ignition as much as this past 12 months. I don't know what's changed. I don't know whether I just live on the wrong side of the street. But here's an igniter on the left that is brand new. The igniter on the right is off of a TFT boiler that had delayed ignition and blew the stack right off it. The technician reinstalled it, fired it 3 times, said everything's fine, and left. And 4 hours later, it blew off again. And the housewife called me up and said, I want a new boiler. This thing's defective. When in reality, if you pulled that igniter, you can't even fit a business card through it, the one on the right. So what's the correct gapping? You can thank Jason Thompson for this one. check the gap. It's supposed to be 3/16 of an inch. And I was referring to Jason about setting the igniters on an oil boiler with a nickel, where we used to put them on the nozzle and slide the igniters into the nickel, turn it sideways and swing them in so that the nickel's tight. And there was your gapping. So stack 2 nickels and put them between it. It should be slightly loose. So very easy. You don't have to try to measure it. Just grab 2 nickels out of your pocket and try it. But if you can't, you have to try to bend them so you do. I will say this, it's not an oil boiler. These igniters are in the flame and getting annealed. I can tell you that in trying to bend them with 2 wrenches so you don't break the ceramic, you have a high chance of breaking the metal. So the best way to do it, if your gap's off, is to replace the stupid igniter.
And the only time it'll break is when you don't have a spare.
Same as ripping the gasket when you pull it off, Dave.
Yeah, exactly.
Yeah.
Mm-hmm. So the other thing to check
Again.
and to make sure you have flame is to hang the igniter off the boiler. Turn the gas off so you're not blowing raw gas into the burning into the chamber, and turn the boiler on. And in the words of my son, who I had him do this because he is 45 minutes away from me, and he did this on his boiler, and he went, "Christ, Dad, it looks like a plasma cutter." That's right. We use a 10,000 volt ignition system on it, and yes, it will look like a plasma cutter. Do not let the igniter cable rest upon your hand or anything metal, and make sure that it's free and clear of anything on the boiler, so when it arcs, okay? So that way you know you have flame. If you don't have flame, then you gotta check to see if you have power going to your transformer, and if you do and you don't have spark, it's either an igniter or it's the transformer.
I will say, guys, one symptom that's come up a couple of times recently, I have seen spark transformers that give you a sort of intermittent spark. So when that spark comes on, it's a continuous solid buzz for, I'm going to say 5 to 7 seconds. If it stutters at all and you hear like a bzz, 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 and it kind of stutters, it might still look really strong, but if it's stuttering at all, you probably have a transformer issue. And you're better off just not keeping it. So it's not a common symptom, but keep an eye out for it because it, again, causes delayed ignitions or no ignition sometimes.
God, I love you, David. I just learned something new. Gas valves. Now, I happen to pull some of these pictures off of our NTIBoilerparts.com site. I have some of the pictures that I've taken. These are pictures of gas valves that we use on all of our residential boilers. And I just want you to look at some notable differences. They're all very similar. They work the same, but they're all very different. So the TRX and the FTVN. For some reason, we finally started telling people how to use the offset screw, which is the screw under the T40 cap, which is directly underneath the orange right here, the T40 cap. And they've been using that to try to set combustion. And once that's done, we always thought we were kind of screwed and needed a new gas valve because there was no way to reset it. But we do have instructions on how to set it. On this boiler, here, the 4 millimeter or 5/32 Allen key. On this particular gas valve, all the other gas valves in our line, if you want more gas, you turn it to the left. On this one, if you want more gas, you turn it to the right. So don't be confused with that. So I just have something that someone put together for me here, or put together for us. I think this will be kind of fun to watch. So Dave, this might look familiar to you. Let's see if I can do this. Oops, nope. Why aren't you starting, Mr. Program? Pardon me for 1 second, I'm getting it.
To begin the gas valve reset procedure, connect your manometer to the R port on the left side of the valve. Do not remove the screw, just back it off approximately 2 turns and connect your manometer. Once the manometer is connected, adjust the throttle screw till it is fully open. To do this, turn clockwise until the screw comes out flush with the plastic housing. Once the screw is flush, the valve is fully open. Now carefully turn the screw counterclockwise 4 complete revolutions.
This should bring the valve to an approximate factory setting. Now you can complete your high fire combustion analysis and set the valve for the specifications in the manual. Next, remove the cap from the low fire adjustment screw. Keep the cap, you'll need it again. Now you want to adjust the low fire adjustment screw while the boiler is running in low fire until the pressure on the manometer reads 0. On this valve, the pressure is already reading 0, but you'll notice that as I increase the gas flow, the pressure will go positive and become a bigger number. And this is by turning the screw clockwise. And if I decrease the gas flow by turning counterclockwise, the number will become negative. Ensure you zero your manometer before beginning this procedure. Carefully and slowly adjust the screw until you see approximately 0 inches water column on your manometer. At that point, you can now complete a low fire combustion analysis. Use the specifications in the installation manual to set the CO2 to the correct setting. That completes the gas valve reset procedure.
So you know this is a common problem. If we went to all the trouble of making, David went to all the trouble of making a video on it and a handout, and that handout that explains everything that was on that video is in your handouts. That's under handouts on your drop-down screen. So gas valves, put your manometer on it, and on a call for heat, does the pressure drop and does it stay dropped until it stops calling for gas? This is a good sign that it's actually operating. On a TX, is it full of water? That's always a fun one. Just take it off. It's easy. It's just 2 T20 screws. Take it out, and you'll see if there's water in it. Make sure to set the high and low combustion on it, and see the attachment, because I actually wrote a white paper on this on how to set high and low combustion on a Dungus valve. So it's very easy to do. It's a flat bladed screwdriver to adjust your high fire, and it's a 2 or 2.5 millimeter Allen key for your low fire. That turn on the low fire should be less than 1 or 2 seconds on a second hand, although the flat bladed screw should be, no, you can turn that a half a turn at a time. If the screw stops, stop turning. Don't force it further, or you can break the stem that goes to the little dike that covers the hole, or uncovers the hole in that application. Gas valves. Do you have voltage? Is the gasket in the right place? This happens to be the Honeywell gas valve. Top right hand corner, you see the gas harness, the harness that goes to that gas valve. That's a Dungus gas valve. And on the bottom left hand side, you see a Honeywell valve. I find something funny with rectifiers. So that little black thing is a rectifier that changes AC to DC voltage. And you test that voltage to the outside terminals. There's 4 terminals on it. The 2 outside ones will give you the voltage. Set your multimeter to automatic and put it on there, and you should have a constant voltage. I find that under load, that rectifier will break. Sometimes they break completely, but just like Dave was talking about the transformer giving you little sparks here and there, or being interrupted along the firing rate, I find that sometimes these will give you, without load, will give you the change in voltage. But I find that when under load of the gas valve, sometimes they break when they get hot. So it comes in every toolkit. It's a good part to have, because yes, they do go bad occasionally. If that's good and you're getting voltage there, chances are that your gas valve's bad. When you take the gas valve off of a TFT or an LX boiler, there's a cork gasket. That cork gasket is held on with little tabs all the way around the hole where the gas valve attaches, where the Venturi attaches. Make sure that you put the gasket on first so it doesn't slide, and then put the Venturi gas valve assembly back on. If you put the gasket on the Venturi, I've had on multiple applications, it slide down and cover the hole where the gas goes, where the gas goes through, and you don't want that. You can't dial in the CO2, but you have high CO. Possible causes: blocked orifice, we talked about that. Sticking flappers, we discussed that. Hey, Dave, have you found anything to clean and lubricate the flappers yet that works?
The only thing I can think to use would be clean it with like soap and water. If you used anything, I would say something very light, like you can buy a silicone lubricant spray at your local hardware store. Something like that would probably be appropriate because it won't hurt the plastic and it should lubricate the bearings. You don't want anything greasy or oily because you'll make it worse. You need something very thin that leaves just a very, very fine coating that's not going to attract dust. So like a silicone spray lube would probably be okay.
Cool. I also suggest when you're reinserting an older Venturi that you take the O-rings off, and then take an O-ring off, you squeeze it aside and pull it, and it'll come off. You can take it off. Just make them shiny with some silicone grease and put them back on. It'll make it easier to slide in, and it will ensure that you have a good seal around the Venturi and it can't pull air in through it. So something I started doing. Gasket leaks. Dave and I have had a couple applications, and maybe Jason and Ted have too. I know for a fact Dave and I have, where people have put the gas valve back on and or the blower back on and broken the tab on it, or not gotten it flat, not tightened the screws down evenly and broken one of the tabs. You can pull air in there and you'll never know it. You'll think it's tight and it's not. So make sure that when you tighten things down, you tighten them down evenly across the board so the gasket gets seated. So next up, blower seal leak. And David, you guaranteed me you would discuss blower seal leak.
Okay, so you're going to have to use a bit of a visualization here, but the blower always consists of an aluminum housing, and then on one side of it you've got like the black plastic where the motor is housed. The motor has a shaft in it that sticks through the aluminum and into the housing. There's a seal that surrounds the motor shaft, and not in all cases, it actually seems to be specific to boilers that have the dual Venturi, so the ones that have a flapper. So it's something to do with that type of blower specifically. If that seal fails, and it can fail for a number of reasons, such as flue gas getting sucked in, it can be caused by flue gas reversion, which we can talk about, which is not necessarily your fault. It can be, but it could not be. And that's where flue gas just naturally wants to migrate backwards through the intake pipe because Mother Nature hates you. It happens sometimes. Most of the time it works well, but sometimes she doesn't like you. What'll happen is that seal can either rot out, or if you have a bad backfire, I think it can also blow out of place. And there's one way that you can guarantee that you'll find out it's bad, and you're going to reach around the back of the blower and just gently push on the motor housing. Don't push so hard that the impeller starts to hit inside, but if you push on it gently and all of a sudden your CO2 numbers shoot up and start to come into range, because the symptom is usually that you're running too lean. If you push on the back of the blower and your numbers jump up 1-2%, odds are guaranteed you've got a bad blower. If you push on it and nothing happens, it's kind of 50-50. If everything else is perfect, it's a bad blower. But make sure you've reset the valve, make sure you've inspected those orifices, because the most common symptom is going to be that the orifices in the Venturi clog up and you can't set combustion. 9 times out of 10, it's going to be those orifices. 1 out of 10, it'll be the blower. And probably 1 out of 100, it will be the gas valve. So if you think it's a valve, really double check, especially if you are running, but maybe you're just running lean. If you run lean, it's almost never a valve. But could be a blower, could be a Venturi insert. So hopefully that provides some light. I'll try and do a video. I'm going to do a video specific to that topic. And we'll have that hopefully up on our website in, I don't know, a couple of weeks.
So some things I didn't put in here for pictures. The strangest no combustion problem I had was on an old boiler that was named after the holes taken out of a donut. Might have come in a plastic box, and there was a big enough gap in there where things could crawl into the burner. And the call came to me that was the contractor had bought 3 igniters and 3 flame sensors, and he said apparently they had a bad run on them because none of them worked. And I said, well, it's not the problem. And it was much like it was built with the same burner door as our LX boiler. So you could take the actual burner tube off. That's a tube that goes up to the burner door from the blower. So I said, take the burner tube off and see if you have anything stuck inside the blower. And those of you who've been to my training have seen that picture with a bat inside the burner tube. And when I talked earlier about cleaning the burner tube, he took the bat out, reinstalled it, everything was fine. At that time, I mean, this was 15 years ago, I had no idea you could clean these burners with water like we do, like we tell you now. And it worked. It worked for many years before they replaced it. So that was pretty cool. Dave, what was the strangest one you saw?
You know what? I honestly can't think, although I have seen a similar one where it was a mouse that got up into the burner, complete with tail, and I have no idea how he managed it, but it was an LX style again. And when you looked at the vent termination on this thing, it was a 3-inch pipe, 30 feet in the air, sticking 1.5 feet out from the building, and somehow the mouse got in it, through about 80 feet of venting, up through the blower, through the extended air tube, and then obviously died in the burner. And that was an ignition. It was a local restaurant, the one Tondi's. Anybody that's been to the factory for a factory tour, you've probably eaten there. I hate to say it, we had a mouse die in the burner of the boiler there. So don't know how it got there. It just amazes me to this day that a mouse even got in there.
Wow. Which restaurant was that?
Tondi's.
Oh, it was Tondi's.
Yeah, we've got an LX 200. Actually, I think it's 2 LX 200s and 2 like S120 storage tanks.
Wow. Very cool. So, Ted, what was the strangest one you saw? What's that?
I was going to say they're going on about 12 years old now.
Wow. Yeah, well, we got them out there for some time. Teddy, you see anything strange you want to bring up?
I would say the remains of an animal that I'm going to say is unidentified.
You know what, Steve? Now that Ted said that, I do have goes back to a don't assume story. And this is going back, do you remember Ian we had in tech sport? This is going,
way back.
This was in Ian's day. And this guy still holds the records for the most bird in one intake pipe. He called us at like 8 or 9 in the morning. Boiler won't light. Did you check the intake? Yes, I did. Okay, great. So we move on. We check the igniter. We replace it. We check the flame rod. We replace it. We checked for gas pressures. We did the whole thing. And somewhere around 3 or 4 in the afternoon, Ian says to the guy, okay, let's just start over. Take the intake pipe off the boiler. And he responds with, well, I can't. And so Ian was kind of blunt and he said, well, how'd you check it the first time? He goes, well, I went outside and looked at it. He goes, okay, cut the vent off. Cuts the vent off. And the guy's like, oh, wait a sec, there's something in there. And he started pulling out birds. And it was like, oh, there's one. And he's like, oh, no, there's another one. No, there's 2. And this went on 7 birds. Still the most in any one intake. And so don't assume. If you're the second guy on site, and even if you're the guy that was there the last time, don't assume he knew what he was doing. I can't tell you how many times this idiot here was on site and forgot to do something.
At the moment, I didn't, because he shot me.
I want to say there's a number of times I left our previous owner without heat or hot water because I was showing a new guy a feature on the boiler that heated his apartment. And he'd call me on Saturday and say, Dave, were you screwing around with my boiler again? And I know for sure I changed that setting. But anyways, so even if you were the last guy, start from scratch, do it very methodically, make sure you check. It's not good until you see it's good.
Yeah. So we have bird screens on the intake now that we give you, and there's a garbage screen inside the blower. I mean, inside the burner, right at the top of the burner where the adapter is, and you can see that up through the gap on the new boilers. So you can shine a flashlight up in it. It is not cleanable from inside the boiler. You do have to remove the air intake. So be aware of that too, gentlemen and ladies. Jason, you got anything you want to throw in on that? He's shaking his head no, so I'm assuming I'm going to see the top of his head and the bill of his cap going back and forth. So I'm saying that's pretty good. So it's been the month of I guess the last 2 months has been months of bad combustion, and I've had problems with the methanol, the amount of methanol somebody's pumped into LP tanks to try to get them dry. I've seen frozen regulators, bad gas valves or gas valves that won't adjust, blowers that are there. But the big key to this is to go through your combustion and troubleshoot everything across the board to make sure that you have everything set before you go replacing parts. So I can't underline that enough as to what you got. So Dave, you have any other tips on going over this? We have a couple minutes left.
The biggest thing is be methodical and make sure you're being thorough. Check those intake pressures, check the exhaust pressures, and don't look for. I think sometimes people get it in their head that there must be something just magically wrong with their boiler. There's tens of thousands of these things, whether it's ours, Lochinvar, Weil McLean, whoever. They all work the same. They all need air. They all need gas. They all need spark. So if you read the instructions we put in our book for fixing an ignition failure, it's the same for every other boiler manufacturer. All that changes is the code. They all work the same. So look for air leaks. Those are ones that really give guys a lot of, oh, yeah, here's a good one. Inspect your igniters very carefully. Look for pinholes in the ceramic or carbon tracing.
Oh, I remember that one.
Yes, we have igniters that you'll hang them out of the boiler and they work just perfect. They're a nice strong buzz, nothing wrong with it. You stick it in the boiler, it stops working. And what's happening is that it leaks through the little hole in the ceramic, arcs to the refractory, arcs to the burner door. It arcs anywhere except where it's supposed to, but only in the door when it's in the chamber. So inspect those igniters. If you see what looks like a little dot from a black pen, there's a good chance you're getting carbon tracing, and what's happening is the spark is leaking out through that. And it threw us for a loop. I'll be honest. It was a tough one.
That was barely visible too, if I remember correctly. When we looked at the ceramic, it was almost
subtle.
I mean, it was extremely small. I was shocked at the size. Yeah.
Very, very subtle, but boy, oh boy, what a learning experience on that one. Beyond that, yeah, again, make sure the air pathway, if your boiler can't breathe, it's not going to run. And the air pathway is inside the burner. It's anywhere from where the exhaust starts to where the intake starts, the exhaust ends. That whole thing, front to back, including the blower, the burner, the extended air tube, the combustion chamber, all needs to be clean. And the only way to know it's clean, and I know it sucks sometimes, is to take the door off and wash that burner, even if you think it's okay. I've had burners, 2 or 3 techs now, back and forth, and they're like, no, it's fine, it's fine, it's fine. I'm like, oh, just go wash it for me, humor me. And they come back and they're like, hey, it's working. I wonder what changed. It's like, just do it. Sometimes that extra 15 minutes is all you can do when you call for a no heat or no combustion. I can't tell you what's wrong. I can only help you find what's not wrong. And the only way you know what's not wrong is when you've personally verified, like to the nth degree, it's clean, it's clear, it's working.
Yeah, I had a TFT, an old TFT that when we had the solid ceramic, the big white ceramic insulation, and the guy pulled the igniter and broke, when he was reinstalling it, he broke the insulation. And then, of course, it really wouldn't fire now, right? So, because all the holes are blocked. So that's a fun one. He pulled the burner door, said, I found the problem. You shipped me a boiler with broken insulation. I said, but the boiler's 3 years old. He says, well, I know that's the problem. I'm like, yeah, never mind. So I've had the insulation, the cloth insulation, where there's been a loose thread where, they're supposed to burn the edges when they cut the hole. It's actually done with a laser cutter so that the edges are clean. And think of it like a pair of cutoffs. You're nice and clean when you cut them off, and a week later you got all these little strands, right? So it only takes one little strand to go to that igniter or to go to the flame sensor to ground it out. And it just takes a minute when you have the burner door off to look at that closely and trim it with a fine pair of scissors, or even burn it with the end of a cigar if you have to, but I've always used scissors, and trim it off, and all of a sudden the problem goes away. So these are little things you got to look for that.
Yeah, no, that one's is subtle. And another subtle tip is I called it flue gas reversion. If you shut the boiler off, hold your hand over the intake, like right where the blower is, like right in front of the Venturi. Just hold your hand there for 30 seconds or a minute. If you can start to feel warm, moist air coming back towards your hand, even if the venting is perfect, it means you're getting flue gas reversion, which means Mother Nature probably doesn't like you. And for some reason, instead of the flue gas rising up and out the stack the way it should, she's decided that the pressure in the room or in the intake pipe is less than the exhaust, and it wants to suck backwards. What that's going to cause is moisture loading in the refractory. And so if you get these jobs where, again, you'll notice the Venturis will break down a little quicker and they get a little bit dirtier. The only tool in your arsenal to fix that is a longer post purge. And I mean, you can redesign the venting, but that's the problem is I can't guarantee that it's going to work no matter what you do, because already Mother Nature has a strike against you. But the best thing you can do is put a longer post purge on that boiler if it's adjustable, and that'll help prevent the moisture from doing damage. And that can cause you intermittent failures, because when you're short cycling, your refractory is really wet, it conducts, and once it dries out and you show up, it's great. It's, it works perfect. So
Yeah, it's I mean, we found some really weird ones along the way, and I had a brand new boiler the other day. It had run for about 5 minutes and shut down, and they couldn't get it restarted. And we tried multiple times, and we finally actually reset the high fire screw, which David told us, you back it out till it's flat and then turn it in 4 turns, and then try to fire it and turn it in 1 more turn. Try to fire it, try it 1 more turn. And if it doesn't fire, just try putting 3 fingers over the Venturi or over the inlet on that one, and see if you can't get it richened up a little bit to go. But we finally did get that one going. But the funny thing is the way it shut down, I was pretty nervous about it. So I had him pull the burner door. We pulled the burner door, checked the burner, checked the insulation back door. There was pieces inside the burner. We took them out, reassembled everything, and in less than 30 minutes, we were back up and firing. So don't think this takes forever, because everything we just went through is a 30-minute process if you do it systematically and go through it and make sure that you have everything covered. Brand new boiler, you're not gonna have to wash the burner out, but there could be crap that was blown into it. You could have something in one of the blower blade, in one of the blades, like I showed you. You could have a loose gasket somewhere. I mean, we build these, we test them, we run them. So does most people test some of their boilers, but we can't help what happens and shakes loose in shipping. So.
And we've seen this a couple of times too for the fire tube guys out there. 3 times this winter, right in the condensate dish, right at the base of the boiler. So you're now all the way inside the boiler, right at the very bottom of the boiler cabinet where that condensate dish is. We found a dead animal in one. I think it was a bird. And I say think because there wasn't much left of it. But we did find feathers, so we're making an assumption there. And we found another one that was clogged up with PVC shavings. So it probably was a fairly new job, but there was enough shavings in there to clog the drain, and it was providing just enough exhaust back pressure and problems that the boiler was really struggling to stay lit. And anyway, and again, I've only seen that 2 or 3 times in the entire time we've been selling fire tube boilers, but never assume it might just, if you have to, take that condensate trap off, poke something up inside there, or spray some water up just to make sure, because even on a new install, it happens.
Well, you say that, Dave, and I had a brand new install that wouldn't fire, and when they put a manometer on it and started the boiler, the gas pressure dropped to less than an inch. It dropped from 7.4 to less than an inch. And they went out and 2 instances. One, somebody had were mad probably at the installers and shoveled a handful of mortar inside of the gas line going across. And the other one was a bad regulator outside. So, these are things that we have to look at also, right?
I was on a site with 2 TFTs. This is going back a long time, but one of them worked perfect. The gas pressure was fine. The other one, you couldn't set high fire, for example, and the gas pressure was dropping off. And most people would look and say, well, it's a common, and it was a common gas regulator, but it was, there was 2 supply pipes. Anyway, somewhere out behind a bush, somebody had leaned on the gas valve and shut it 3/4 of the way off. And it was just 2 valves side by side. One was open, one was half closed, and it, we didn't see it for a little while because we had to go looking for this valve.
Wow.
One guy 2 people that really gave me a hard time, and they were nice enough, but they kind of gave me a hard time because I kept saying, you got a gas line problem when the gas pressure dropped to like 0 inches, and they're like, no, we don't. It's brand new. It's good. Anybody ever buy a pipe nipple wrapped in plastic? Well, this guy did. There was a dime-sized piece of plastic just right over the end of the nipple.
No
Perfectly
shit.
sized, so it had just when he ripped off the plastic, it stuck on there, and that was all that was wrong. And then I had another guy, and he fought with me for about an hour, and finally he gave up and decided to go check his gas line. And he found spray foam in there. I don't know if it was deliberate or accidental or how it got there, but it was full of spray foam. And he called me back and he said, look, I'm sorry, it was full of spray foam. And so if you're losing pressure at the inlet to the, another one, again, story that really kicked my ass for a couple of hours. TFT, and the TFT, when you convert it to propane, the orifice goes either in between the Venturi and the valve, or it's, well, really, it's always in between the Venturi and the valve. And the person I was talking to was checking at the drip leg at the bottom of the boiler, and the gas pressure was perfect. But at the valve, when we checked the valve, the pressure was dropping to 0 every time the boiler fired. Apparently, they hired somebody that took off the elbow that connects the gas line, and he just shoved the orifice in there and bolted it together. It really took some finding on that one, because the guy wouldn't believe me when I said there's a problem in the gas line, and there was. And I don't know if his tech still works for him, but and the only other one I've seen that's strange, and I haven't seen it much in the last few years, but in the old TI days, the regulator that's on the valve is held on with 3 screws. And when you take it off, there's a diaphragm and a spring in there. If any of your techs calls you and says, I'm converting to propane, and they say, well, what about the spring or the diaphragm? I'm not going to say fire them, but talk to them. They are clearly not looking at the instructions.
I've had that happen a couple times. So,
yep. And what about the spring? Spring? What are you talking about?
Exactly. As soon as they say spring, you know you're screwed. So
yeah, as soon as they say spring, you just buy yourself a valve.
Yep, exactly. The drywall dust, construction shit in burners, you can see the blades, especially with drywall dust. If you look at the blower blades, they're white. You know your burner's got to be cleaned. I mean, don't even go any further. So
yeah.
And one last thing, real quick, Dave, give me your top 5 things of why you would have high carbon monoxide and not be able to fire the boiler. Quick, go.
Top 5, recycling flue gases, really dirty combustion chamber, damaged flapper or Venturi is screwed up.
Blocked. Running
too lean, oddly enough, because when you run too lean, the burner becomes unstable. You get excess CO. Number 5, you're actually, there's 2. I'm going to give you 6. You're set to the wrong fuel type on your analyzer. And this one I see a lot, and this comes up an awful lot lately. Make sure the analyzer is 100% sealed in the test port. I don't care if you have to tape it in there. The tiniest amount of air leakage, and I mean the tiniest amount, especially at low fire, will cause you headaches that you can't imagine. And it's easy to do, especially on the TRXs. The small TRX has a really tight hole for the combustion test. And at least the analyzers we have at the factory have a relatively large wand. You really have to shove it in there tight. And if you don't, it will read wrong, because your analyzers don't read CO2. They read oxygen. So any air that leaks in, it's going to give you the wrong CO2 number, and you're going to keep adding CO2 until you're just overfired, your CO's off the charts. And I would say that's the most common reason, is the analyzer is not sealed in the test port. Also make sure your filter's in line. Snap the filter together, make sure there's no cracks in the tubing. Huge problem, I would say, because we see it almost daily.
Wow. So there's a whole bunch of crap for you guys to go through. We're going to hit some of these in depth when we get down around it. Should be kind of fun. I can't tell you how many jobs I've been on where, you know, humming at low end and people are afraid to set low fire. And Dave and I were discussing this earlier today. When you go from high fire to low fire, don't even look at your combustion analyzer for a minute and a half. Because if you do, while it's dropping down from high fire to low fire, you're going to see your CO go off the charts, your O2, it's just going to go everywhere. Relax, it's okay, don't touch anything. Let it get down to low fire, let it adjust itself and even itself out. And then a minute and a half to 2 minutes later, you're okay.
The key word with low fire particularly is patience.
Absolutely. Yes. So
guilty as charged.
all of us. The first time I saw it many years ago, what 15 years ago, Dave, when I was the rep, right? And
yep.
And I saw it, I went, holy shit! And the first person I called was Nicholson. I said, what's up with this? He goes, relax, Wheels. It's okay. We're going to, it'll be there in a second. Go slow.
Yeah.
And baby steps on low fire. Those screws, depending on the boiler, can be, like Steve said, 1 second on the clock. To some of them are, maybe 1 hour, but some of them, some of the older Honeywell valves, like 1 or 2 seconds on that adjustment. You breathe on the screwdriver and you've gone 0.5%. So just be patient with them.
By the way, I know that the guy who,
and when you make an adjustment, give it time to settle out. Again, refer to the patience part. Yeah.
I know somebody has tried to set the combustion with the offset, with the low fire offset, because when I get there and I take my T40 to take that screw off, it's loose. And from the factory, they put them on with pneumatic guns. It's easy. So cool. All right.
Yeah, I'm gonna look at seeing if we can create a couple more gas valve reset videos for some of the other boilers, but I got to talk to engineering first and make sure I'm not gonna make anybody unsafe before I do that. But if I make them up, who knows? I got to talk with them first. But we're gonna try and get you 2 or 3 more videos like the one Steve showed you. Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.